Solution set. In this part, we're going to introduce homogeneous equation, non-homogeneous equation, kernel, and null space. Actually, these two concepts are the same, but this null space is used in our textbook, and kernel was used in our web work. So that's why we want to introduce both, although they are the same, and particular solution. So all those concepts are related to solution set of a matrix equation. So we are given a matrix equation Ax equals b. Then if b equals 0, then we call this a homogeneous equation. If b is not equal, then we call this non-homogeneous equation. And what is kernel and null space? Kernel and or null space, they're the same. So we said in some different places they use kernel, but our textbook we use null space. So given a matrix A, we can always talk about what is kernel. So the kernel is the solution set, or the collection of all the solutions satisfying the homogeneous equation Ax equals 0. We first look at one example here. So A is given here, and Ax equals 0. This is homogeneous equation associated to A. Now first we want to find solution set, and we want to use this solution set to represent what kernel A is. Kernel A is a family of all solutions satisfying this equation. So first, if you find solution set, then kernel A is straightforward. So for the equation, we first look at the augmented matrix, which is 1 0 0 1 1 0 2 1 0 on the left hand side of the bar, separating bar, and right side is just simply 0 0 0, because this is homogeneous equation. Now we first look for a staircase shape. This is REF obviously, but unfortunately this is not REF because of this spot. So I will mark two pivots in the first column and second column, and the third column has no pivot. In other words, x3 will be free variable. Now I'm going to kill this spot. To do that, we will do R1 minus R2, replace R1. So 0, 1, 1, 0, second row, third row, there will be the same as before, but the first row will be changed as 1, 0, 1, 0. Now we get REF. This is REF. To solve it, we want to switch this into original the linear system. So we put x1, x2, x3 back into the equation. So from the first row, we get first equation. So 1 times x1 plus 0 times x2 plus 1 times x3, which gives me the other side 0. This is first equation. Second equation is from the second row, which is 0 times x1 plus 1 times x2 plus 1 times x3 equals 0. Now the third equation, the third row doesn't provide any equation because this is all zeros. Now from the third column, we do not have pivot, so that means x3 is free variable, so we need to move this to the other side and solve for x1 and x2. So if we solve for x1, then this is negative x3, x2, then negative x3, and x3 is the same as x3. So at this point, we can write x as put out x3 from the vector and put the coefficients inside. So here negative x3 means this is negative 1. And negative x3, the negative 1. And x3 means this is coefficient is 1. So this is PVF, parametric vector form. We're done. This for the first question. We solved it. And this is the solution set. What is kernel of A? So the kernel of A consists of all the solutions satisfying the AX equals 0. So one can write this as using set notation. So you can write this x3 and negative 1, negative 1, 1, and x3 is any real number. But this is a more common notation is following because we have introduced what span means. Span is the linear combination of given vectors. So there's only one vector. So this is basically span of one vector, negative 1, negative 1, 1. So this is more common notation. Next, we look at a proposition which is a little bit more abstract, but we're going to give a brief proof. So suppose P1 and P2 solve the same equation AX equals B. Then the difference of two solutions solves homogeneous equation associated to the same coefficient matrix. So given two solutions P1, P2, then by solution it means it satisfies the equation by if we replace x by the solution. So AP1 equals B and AP2 equals B. Now we're going to subtract each other from, so left hand side minus left hand side means AP1 minus AP2. We can take out P1, so do subtraction. AP1 minus AP2 means A outside and P1 minus P2. And B minus B, B minus B, right hand side minus right hand side, basically 0. So what does it mean? P1 minus P2 satisfies the homogeneous equation. So we're done. Now the second one. The second proposition is very similar, but the argument is opposite. Suppose P is one of the solution of AX equals B. So P is some particular solution of a non-homogeneous equation, and V is solution of homogeneous equation. Then P plus V solves AX equals B. So because P solves AX equals B, we can write AP equals B. Now the other one is with V solves AX equals 0, so AV equals 0. Now this time, to get the conclusion, we add them together. So left hand side plus left hand side, which gives me P plus V. And right hand side is B plus 0, which is B. So compared to the matrix equation, AX equals B, obviously P plus V solves AX equals B because it can be, they have P plus V can replace X in the equation. So we're done. So pause a little bit. After the proof, we think about what this proposition means. So P, suppose, so we're going to solve for AX equals B. It might have multiple solutions, but suppose you find one particular solution of AX equals B, and if you know the solution set of homogeneous equation, then particular solution plus homogeneous equation solution gives me the whole solution set of AX equals B. So this is what it means. Particular solution plus V solves homogeneous equation. In other words, this is from kernel. So kernel is the whole solution set. All right, now we're going to look at another example and try to apply this, our proposition previous about the description of a solution set. Consider a matrix equation AX equals B. A is given as before, B is non-zero, so this is non-homogeneous equation. This is non-homogeneous. Now, there are two questions. Check a candidate solution given by X equals this is a particular solution. And write its solution set in vector form, parametric vector form. So the first question is just plug in and check if this is true or not. So this is 1, 1, 2, 0, 1, 1, 0, 0, 0, and X is 1, 0, 2. Is this 5, 2, 0? This is just computation. For example, from the first row and first column, we can see that row vector multiplied by column vector, this gives me 1 times 1, which is 1, 1 times 0, which is 0, 2 times 2 is 4, so in total this is 5. And we can do the similar things for all three rows, and the answer is yes. So we're done. So this is actually a particular solution. Number 2. Write its solution set. Of course, we can solve AB, the augmented matrix, and get REF and find the solution set. This is one possibility, but now we are going to use the previous proposition we derived here. So the solution set is particular solution plus the kernel. What does it mean? So for this example, we already have one particular solution. We don't need two particular solutions. That's too many. So only one is sufficient. And then we need kernel structure. The kernel structure is given by here. So this is kernel, so this is kernel structure. All right, just add them together. So alternative way to find the solution is X and the solution set, or maybe we can just write its solution in PBF form, in vector form. First of all, particular solution 1, 0, 2. This is one of the solutions. And any solution from the kernel. So we know that any solution, which is one of the solution is given by here, -1, -1, 1. -1, -1, 1. And multiplied by any number, it's still in the kernel because the kernel is span of this, so linear combination of this one vector. So this is PBF. All right, here's a conclusion. So if the solution of AX equals B is in parametric vector form, which is X equals a particular solution plus linear combination of V1, V2, and Vk, then this particular solution solves, of course, AX equals B. But any vector following by free variables will solve homogeneous equation. And in other words, the span of V1, V2, Vk gives me the kernel of A, or null space of A. And the solution set can be written as particular solution plus kernel. Another tip is that the following three statements are equivalent. So if A0, the augmented matrix, has no free variables, then there's only one solution, and this solution is trivial solution. In other words, x is 0, 0, 0, 0. So AXX equals 0 has unique solution, which has to be the trivial solution. And the columns of A1, A2, AN is an independent set. All right, this is the end of this slide. Thank you.